I will explain about punch-through in VLSI, low power VLSI design. Here the punch-through means it is almost same as drain-induced lowering barrier, like that only. But here we are not giving any extra supply to the transistor. So because of that there is a chance to flow the current from source to drain in. As you know that, I will explain. You know that the function of the transistor while giving the input signal, as usual, it is amplifies the given input signal and it stores the data. This is the transistor, and this is only the symbol. It amplifies the given input signal. It amplifies the given input signal and it stores the data. So of course in low power VLSI, and there is a chance we need to reduce the power dissipation in low power VLSI. But here there is the power dissipation will exist when it is existing power dissipation. Here we know that if it is P substrate, it is having holes, polysilicon material. From that it is having, we are selected, that is P substrate. To design gate terminal, we are deposited that is polysilicon material at the middle of the substrate, and it is named as a gate terminal. And to design source and drain terminal, we are inserting electrons into P substrate. We are deposited electrons into P substrate. Here it is electrons are inserted or diffused here. So this is named as source, and this is named as, that is, drain. This is named as drain. But internally it is this barrier will merge because of the electric field. This barrier will reduced and merge, and current will flow from both the source and drains, and current will flow from source to drain without any extra supply or extra VDS. So that effect is called as punch through. Here you can see this. Source and drain depletion regions are extended into channel. Source and drains depletion regions are extended. So this effect, due to this, there is the power dissipation will exist. That is called as punch through. Without any extra supply, the drain and source may be merged due to electric field. Due to that, the power dissipation will exist. That is called as, that is punch through in low power VLSI. You can see this. It is also a short channel effect. And MOSFET becomes important when the transistor channel is very small. If the channel is very small, there is more chance to flow the current from source to drain. So as a result, the current will directly flow from source to drain. So that is called as punch through in low power VLSI design. Here also you can see the difference between, that is punch through and IDBL, DIBL, drain induced barrier lowering. So this is the normal transistor. There is no merge here, but here you can see this. So here there is a chance to merge, and current will flow from source to drain. That is called as punch through. Here you can see this punch through, that is the depletion regions are merged. And one more thing we need to observe, this source and drain. If in punch through, source and drain depletion regions approach and merge directly. But when you are giving drain field, drain VDS, that is drain, only the drain field lowers the source channel barrier. It will reduce extra supply here, but here we are not giving any extra in punch through. So causes current leakage, same thing, causes that is subthreshold leakage. Both are disadvantages. So that is the difference between that is punch through and drain induced barrier lowering. Thank you.